batteries. So what exactly is a battery? So batteries are galvanic cells that are portable and self-contained. So it's basically a group of galvanic cells that are connected in a series. So it's a bunch of different ones connected, and the potentials of each individual cell add up to give the total potential of the entire battery. So they're connected in series, meaning that the cathode of one is connected to the anode of the next one, etc. So your cells are, if you have two cells here, and this was your cathode, and then this was your anode. Actually, let's flip that. Hold on. Here was your anode, and here was your cathode. Then this cathode would be connected to another cell, to the anode of that cell. And then that would happen again. So it's always the cathode of one to the anode of another, and this is series. So they're connected in series, and that's how you get a battery. And the overall voltage will be the sum of all of these voltages. And the cathode is always positive, we know that. The anode is always negative. And the primary cell cannot be recharged. But the secondary cell can be recharged. And we'll talk a little bit more about specific batteries coming up here. So just knowing that a battery is a galvanic cell still very specifically connected in series, and it's always the cathode to the anode, and that the total voltage is the sum of all the individual voltages of the cells. Now, looking at lead storage batteries specifically. So a lead storage battery is mainly in cars, and a huge factor in what makes them up and how they function. What happens is that there's plates of lead and lead oxide in sulfuric acid. So here you can see these little plates, right? So the gray one is your lead, and the green is the lead oxide. So there's a bunch of these plates, and they're placed in sulfuric acid, which then creates a cathodic and anodic reaction. So the anode reaction is the lead with the hydrogen sulfide, and the cathode reaction is the lead oxide with the hydrogen sulfide. Knowing that the hydrogen comes off in solution, making it an anion that's reacting with these different lead and the lead oxide. The overall cell reaction then is here on the bottom. The lead oxide, hydrogen ion, hydrogen sulfate, making lead sulfate and water. So when 6 of these are connected in series, we can get a 12-volt battery. And the reason that I say that is because the overall cell potential is around 2.041 volts. So when we get 6 of them, we get around 12-volt battery. The anode being the lead and the cathode being the lead oxides. Both of these are solids, you can notice that. So there's no need to have to separate the compartments. They both end up getting coated with lead sulfate. They stick to the electrodes so that the battery can be recharged. As this battery is discharged, the sulfuric acid is used up, and we can measure the density of a solution, determine how discharged it is. So the important just to know is that you have lead and lead oxide that are placed in sulfuric acid. And because these are both metals, they don't need to be continually separated. They're already going to react, creating lead sulfate that sticks to the electrode so that the battery can continually be recharged. And then as the sulfuric acid is discharged, we can use that to measure different densities of solutions. A dry cell battery. So this is used in calculators, electronic watches, portable radios, tape players, etc. And it's contained of anode and cathode, like you can see. And what you have is basically manganese oxide and graphite. That's the cathode. And then the anode is zinc, and usually a really concentrated gel of some sort. You have a salt bridge in the middle, which is porous fabric that's sealed. And that's where this battery comes from. What happens here is that the zinc is in the anode, which means that it is oxidized, and the cathode reaction of also the ammonium chloride with the manganese oxide is reduced to give us an overall cell potential of 1.5 at room temperature. So this reaction gives us the battery that's used in calculators, electronic watches, etc., due to these different parts of it. So basically what we're going through is just what these batteries are really made up of, knowing the different components of, first, what is a battery? We said a bunch of different galvanic cells connected in series. Then lead storage battery, what's that made up of? We have the lead and the lead oxide that's in sulfuric acid, knowing specifically what's the anode and cathode reaction, and what is it used for in cars. Now we're talking about dry cell batteries. It's used in calculators, radios, etc. The anode reaction is the zinc, and the cathode reaction is the graphite rod, which has a paste of manganese oxide and ammonium chloride on it, giving us the reduction to give us our overall cell potential of 1.5. Well, of the dry cell battery, there's also an alkaline version of the dry cell battery, where the solid ammonium chloride is replaced with sodium hydroxide or potassium hydroxide. So that's what I was talking about earlier. So still the same functions. However, it's now the ammonium chloride is replaced with a strong base. So then the anode and cathode reactions change just a bit. The zinc has hydroxide that's being oxidized. And then the cathode reaction, the manganese 4 oxide, has water to reduce it to manganese 6 oxide with hydroxide. The difference here between the alkaline version of the dry cell battery and the dry cell battery, adding in this hydroxide actually make this battery last for a longer time. This is because the zinc corrodes less rapidly under basic conditions, and corroding is being oxidized. So the zinc corrodes less rapidly under basic conditions. So what I mean is, having an alkaline version of the dry cell battery, we have a strong base, right? So it's basic conditions. And this battery lasts longer in our calculators and our watches, etc., because it doesn't let the zinc be oxidized. Because see, the zinc forms zinc 2 oxide. So this process happens a lot slower, so therefore the battery itself lasts a lot longer. Then we have a few other rechargeable batteries, one being the nickel cadmium battery. This is really toxic and heavy. Our anode reaction is the cadmium that is oxidized with hydroxide. And then cathode reaction is nickel 4 oxide that is hydrolyzed with water and reduced to form a basic nickel hydroxide. We also have lithium-ion batteries. So lithium-ion batteries are when lithium ions migrate from the cathode to the anode and enter the interior as the battery is charged. And charge balancing electrons travel to the anode through the external circuit in the charger. The opposite process occurs on discharge. So basically what's happening is, if you have your cell here, right, we have cathode. I keep doing that. This is our anode. And then we have the cathode. And then again, anode. I'm just going to abbreviate here, cathode. And what's happening is that lithium ions are migrating, since we know this is a battery, so there's multiple cells that are connected in series, migrating from the anode to the cathode. And that is helping a battery get charged because it's going in the interior. And if we wanted to discharge it, it would go in the opposite direction. So lithium is actually very light compared to the nickel cadmium, which is heavy and also very toxic. Now, last little bit for this section of this chapter is going into fuel cells. So a fuel cell is a galvanic cell for which reactants are continuously supplied. So it involves a spontaneous redox reaction to generate electricity, fuel, supplied constantly. So it's never stopping. It's constantly being supplied, and it's a very spontaneous reaction. So H2O2 fuel cell is twice as efficient as internal combustion engine. It's more efficient because less energy is wasted as heat. So here's an example of an H2O2 fuel cell, and what you can see is the anode reaction and the cathode reaction. And this would give us an overall cell potential for our overall reaction of 1.23 volts. Products of these type of fuel cells do not pollute, so they're actually really, really efficient, and they waste less energy. You can see that you have your anode reaction and your cathode reaction, and they let out steam. The porous carbon electrodes containing the catalyst to make the electrons flow here from the anode to the cathode in this basic water solution to fuel whatever needs to be fueled. So the important part of what I want you to get out of this section is know all of the anode and cathode reactions that are occurring and why. Why is an anode and cathode reaction important? Well, it's because, again, these are all spontaneous because we're still talking about galvanic cells, and that spontaneous process of the electrons going from the anode to the cathode is what is causing a charge, and that's how the batteries give off a charge and, help your calculator work and help a car function and fuel certain things way more than others. So that's the whole point. And what I want you to know is what is in each of these, what's the anode, what's the cathode, and what exactly do they help supply.